So opposite to the hypotenuse, 90 degree, the hypotenuse. So the theorem says that you have to prove that AB square plus BC square equals AC square. AB square plus BC square equals AC square. That is what you need to prove. Now, how we can prove it actually? I need a construction. I'm going to draw perpendicular from B upon AC. So this is the right angle. I have drawn the perpendicular from B to AC. Say it is BD. So that will go to the construction part. Now I have to prove the congruency, the similarity between the triangle ABD and the intertriangle ABC. So I'll write for the triangle ABD and triangle ABC. For the triangle ABD and ABC, how we can prove the similarity? I just need to show that any two angles are equal. So obviously I can show that the angle D is equals angle B equals 90 degree. Both of them are 90 degree angles. This angle and this for the large triangle for the ABC, the angle B is 90 degree. And both the cases we can see that angle A is a common angle between them. The angle ABD, triangle ABD and triangle ABC both has the common angle A. So we can say the triangle ABD is similar with the triangle ABC with angle-angle theorem. As these two triangles are similar, we can say as per the rules of similarity, their sides will be proportional. So AD by AC, the corresponding side AD by AC is equals AB by, sorry, AD by, let's take not AC, let's take it as AD by AB equals AB by AC. So from here we can write that AB square equals to AD into AC. AD by AB equals AB by AC, and that will give you AB square equals to AD into AC. Now we are going to prove the same thing for the other two triangle, and that is for the triangle BCD and the triangle for the triangle BDC and triangle ABC. For triangle BDC and triangle ABC. So again, angle C equals angle C and angle D equals angle B. Both are 90 degree and angle C is the common angle. So as per AA rule, we can say BDC is similar with the triangle ABC. AA property. Now the triangles will be similar, so we can simply say DC by BC equals BC by AC. DC by BC equals BC by AC. Now if you cross multiply, you can write BC square equals to DC into AC. BC square equals to DC into AC. Now you take these two relations, one is first one and second one, and now just add them. We are adding the equation 1 with equation 2. I'm getting AB square plus BC square equals to AD into AC plus DC into AC. So AB square plus BC square equals to, you take AC common, AD plus DC. AB square plus BC square AC into AC. That gives you AC square. Because when you add AD with CD, it gives you entire AC. So thus the theorem is proved. Thus the theorem is proved. Now, we have a lot of questions based on this theorem. So let's try the questions one by one. For example, this is a question given. Two points, two poles of height 6 meter and 11 meters stand vertically on a plain ground. If the distance between their feet is 12 meter, find the distance between their tops. So this is a question given. It's a kind of height and distance question, but here we can simply solve it using the Pythagoras theorem. I don't need to use the height and distance because there no angle is included. So I can simply do it. So first of all, I have to draw the figure. It's given two poles of height 6 meter and 11 meters. So I'm drawing the 11 meter pole. And I'm drawing one more pole, say for 6 meter. This is the 6 meter pole. Okay. Now they are on vertically on a plain ground. So they are on a plain ground. Now the question is, if the distance between their feet is 12 meter, distance between their feet is 12 meters. So let's name them. Say this is A, B, C, D. The BD distance is given 12 meter. The AB is given 11 meter. And this is given 6 meter. Now, we have to find the distance between their tops. So what I need to find? I need to find out the distance between their tops. So I need to find out this distance, the AC line. So under the construction, I will draw one more line which will be parallel to the plane or parallel to the base. Starting from C, it will intersect the AD for say at E. So this is the construction we have drawn. Now how we can solve it? This length is given 6 meter. And these two lines are parallel to each other. So it means this BDCE is a rectangle. Okay, BDCE will be a rectangle, and here this side will become 12 meter and this EB will become 6 meter. So once EB is 6 meter, the AE will become 5 meter. The AE will become 5 meter. The EB will become 6 meter, the AB will become 5 meter. Now, for the triangle AEC or ACE, it is a right angle triangle and I can apply the Pythagoras theorem on it. So we can write that AE square plus EC square equals AC square. So AC square will be 5 square plus 12 square. So it's 25 plus 144, which will give you 169. So length of AC will come under root of 169. That will give you 13. So length of AC will come 13 meter. And that will be the answer, that the distance between their tops are 13 meter. So distance between the tops will be 13 meter. That will be the solution for this particular question. Let's do the next one. Next question says, prove that the sum of the squares on the sides of a rhombus, sum of the squares on the sides of a rhombus equal to the sum of the squares on its diagonal. Prove that the sum of the squares on the sides of a rhombus is equal to the sum of the squares on its diagonals. So we have to prove it. So let's draw a rhombus first. A rhombus means close bounded figure with all the sides equal and opposite sides are parallel to opposite pair of the sides are parallel. All the sides are equal here. And we must draw the diagonals also. So BD and AC are the two diagonals we have. We know that the diagonals of a square bisect each other at right angle. The diagonals of a square bisect each other at right angle. So let's try. What we need to prove? We need to prove the sum of the squares of the sides of a rhombus. So AB square plus BC square plus CD square plus AD square is equals to the square of their diagonals. So AC square plus BD square. This is what we need to prove. That the square of the sum of the squares of the sides is equals to the square of its sum of the square of its diagonals. AC square plus BD square. Okay. So how we can prove it? We know that diagonals of the square bisect each other at right angle. So we can say that OA is equals to half of AC equals to OC and OB equals to half of BD equals to OD. As the diagonals bisect each other, it means each part is half of the entire diagonal. Now we have to choose each right angle triangle and try. So for the right angle triangle AOB, for right angle triangle AOB, what we can write? We can write AO square plus BO square equals AB square. AO square plus BO square equals to AB square. So you can change the AO square as half of AC square and BO square as half of BD square equals AB square. So you just square them. You are getting 1/4 of AC square plus 1/4 of BD square equals AB square. So AC square plus BD square equals to 4 times AB square. Now, similarly, you can write for the other three triangles in the same way. We got here that AC for this triangle we proved that AC square plus BD square equals to 4 times AB square. So for other three triangles BOC, COD, AOD, we can write for each case AC square plus BD square equals to 4 times BC square. AC square plus BD square equals to 4 times CD square. AC square plus BD square equals to 4 times AD square. Now, whenever you are adding this entire thing, these 4 equations, whenever you are adding them, say name them equation 1, 2, 3, 4. Whenever you are adding them, you are getting 4 times AC square plus BD square equals to 4 into AB square, BC square, CD square, AD square. 4 get cancelled. So you are getting AC square plus BD square equals AB square, BC square, CD square, AD square. So that's what actually you need to prove. So thus it is proved. Let's go for the next question. This is the next question given. It's given in the triangle ABC. The AD is the perpendicular to BC. We have to prove AB square plus CD square equals AC square plus BD square. So let's write. In triangle ABC, AD is the perpendicular to BC. We have to prove AB square plus CD square equals to AC square plus BD square. So first of all, for the right angle triangle ABD, for the triangle ABD, what we can write? We can write the AB square, the hypotenuse square equals to base square plus height square, BD square plus AD square. So from here we can write AB square minus BD square equals AD square. Okay, so that is my first equation. AB square minus BD square equals to AD square. Now similarly for the right angle triangle ABD, for right angle triangle we take the ABD, so let's take ADC. We can write AC square equals to AD square plus CD square. So AC square minus CD square equals to AD square. That's the second one. AC square minus CD square equals to AD square. So both the cases we can see these two equations are equals to AD square. So the left hand side of the equation must be equal. So we can write from the equation 1 and 2. From equation 1 and equation 2, we can write AB square minus BD square is equals to AC square minus CD square. So you just need to change, we got all the datas, AB, CD, AC, BD, so we just need to change their sides. So AB square plus CD square equals to AC square plus BD square. This is how we can prove this question. Let's go for the next one. The next question says that P and Q are 2 points on the sides CA and CB of a triangle ABC, right angled at C. So the triangle is right angled at C. So let's draw a right angle triangle. It is right angled at C. The name is ABC. So this is A, this is B, this is C. And it's given the P and Q are the points on CA and CB. So we have to take 2 points on P here and Q here. They are just any points on CA side and CB side. Now we have to prove that AQ square, okay, so we need to join AQ plus BP square, okay, so we need to join BP is equals to AB square plus PQ square. So also we need to join PQ. Okay. So we have to choose the triangle such a way we can use all these datas given. So how we can prove it? First of all, I'm taking the right angle triangle ACQ. There is a right angle triangle ACQ. For the triangle ACQ, we can write obviously that this is the right angle here. So opposite to that will be the hypotenuse. So AQ square equals AC square plus CQ square. AC square plus CQ square. That's the first thing we can do by Pythagoras theorem. Now there is one more right angle triangle which is BCP. This right angle triangle BCP. So for this triangle, what we can write here, the right angle is again at C. So opposite to that is the BP side, hypotenuse. So BP square equals BC square plus CP square. That's the second equation we can write. And the third equation that we can write, that is for the right angle triangle ACB. AB square equals AC square plus BC square. This is the third equation. Square equals AC square plus BC square. Any other right angle triangle is there? Yes, there is one more right angle triangle, that is PCQ. So let's try for that also. For the right triangle PCQ, we can write PQ square is equals CQ square plus PC square. That's the fourth equation that we can write. Okay. Now we have to use all these four equations to get the answer. So what we can do, from the equation number 1 and 2, we can write, we have to add them because look, if you look at the left hand side of the proof, it includes the AQ and BP. So AQ square plus BP square. So in place of AQ, you can write AC square plus CQ square plus BC square plus CP square. Now you rearrange them. AC square will go with BC square and CQ square should go with CP square. So AC square plus BC square gives you AB square from the third equation. And CP square plus CQ square, CP square plus CQ square gives you PQ square. So we can write it as PQ square. So hence it is proved that AQ square plus BP square equals AB square plus PQ square. So using all the four triangles, right angle triangles, we can prove it. Let's try the next one. Given a triangle ABC in which angle A is 90 degree, AD is perpendicular to BC, we have to prove that AD square equals to BD dot CD. So we have a right angle triangle at, something like this. So that's ABC. AD is perpendicular to BC. So we have to draw perpendicular on BC. And we have to prove that AD square equals to BD into CD. So let's try this question. We have again some right angle triangles. So first of all, for the right angle triangle BAC, we can write for triangle BAC, we can write BC square equals BA square plus AC square. BC square equals BA square plus AC square. Now, in the triangle ABD, that's the first thing we can write. Now for the triangle ADB, we can write AB square equals BD square plus AD square. That's the second equation. And for the triangle ACD or ADC, we can write AC square equals AD square plus CD square. That's the third one that we can write. Okay. Now, also we can do what? Now using these three equations, we have to prove that AD square equals to BD square plus CD square. So if I add this to equation AB square plus AC square, what I am getting? AB square plus AC square equals to twice of AD square plus BD square plus CD square. Twice of AD square plus BD square plus CD square. Now, AB square plus AC square, that can be replaced with BC square. So I'm replacing it with BC square equals to twice of AD square plus BD square plus CD square. Twice of AD square plus BD square plus CD square. Okay. BC can be written as BD plus DC or BD plus CD. So I'm writing that it as BD plus CD the whole square equals to twice of AD square plus BD square plus CD square. Okay. Now A plus B whole square formula, it gives you BD square plus CD square plus 2BD into CD equals 2AD square plus BD square plus CD square. So if I simplify from both the side, the BD square, CD square get cancelled. So we are having twice of AD square equals to twice of BD into CD. 2 get cancelled. It gives you AD square equals BD dot CD. That's what is proved. Let's go for next question. So there is a simple change in this two question. It given that in a triangle AD perpendicular to BC such that AD square equals to BD into CD, we have to prove ABC is a right angled at A. So it's a kind of converse of this first question, the sixth question. So let's try it. So this question given that in the triangle ABCD, AD is perpendicular to AD is perpendicular to BC, AD square is equals to BD dot CD, and we have to prove that the given triangle is right angled at A. So let's try to draw this figure. The triangle is ABC. AD is perpendicular to BC. AD is perpendicular to BC. It's given AD square equals to BD into CD. AD square equals to BD into CD. We have to prove that triangle ABC is right angled at A. So we know these two are right angle. So for the first triangle, for the triangle ABD, we can write AB square equals AD square plus BD square. And for the triangle ADC, we can write AC square equals AD square plus CD square. Now this is the first thing and this is the second thing. We are going to add them. So AB square plus AC square is equals to twice of AD square plus BD square plus CD square. AB square plus AC square equals to, in place of AD square, we can write BD into CD. So twice of BD into CD plus BD square plus CD square. So AB square plus AC square equals to, if I rearrange it, it's BD square plus 2 into BD into CD plus CD square. So obviously it is in the form A square plus 2AB plus B square, which we can write it as A plus B whole square. So we can write AB square plus AC square as BD plus CD whole square. Now if you add BD with CD, you are getting BC. So we can write it is as also BC the whole square. So AB square plus AC square equals to BC square. AB square plus AC square equals to BC square. So that means it proves that this triangle ABC is a right angle and it is right angled at A. It is right angled at A. Because otherwise we wouldn't get a relation between the three sides. And how we can say that it is right angled at A? Because it is equals to BC squared. So that means BC is the hypotenuse. Opposite to BC is we have the angle A. So it need to be the right angle. So that will be the overall proof. These two are converse to each other. Next question. The question is given in the figure given below. We have to prove the figure given below. We have to prove that PQR is a right angle triangle and at Q, and the points S and T trisected the side QR. We have to prove 8 PT square equals to 3 PR square plus 5 PA square. So the figure actually given as, this is a right angle triangle, right angled at Q. So P, Q, R. S and T are 2 points on QR which trisected the side QR. So trisected means all these three options will be same, equal. And we have to prove this is 8pt square equals to 3pr square plus 5pa square. Okay. So here we can, first of all, we can write ps equals to st equals to tr equals to, we are taking it as x. Okay. So this is x, qt is 2x, and qr is 3x. That is what we can write. So we have three right angle triangles here, PQR, PQS, and PQT. So for right angle triangle PQR, for the right angle triangle, say for PQS first, we can write PA square equals to PQ square plus QS square. For right triangle PQT, we can write PT square equals PQ square plus QT square. And for right triangle PQR, we can write PR square equals PQ square plus QR square. These are the three things we can write. Now we have to use them. How we can use them? Let's write down the right hand side of the proof. So let's write down the right hand side of the proof. 3PR square plus 5PS square. So 3PR square plus 5PA square. Okay, so the PR can 3PR square. The PR can be written as PQ square plus QR square. So 3 times PQ square plus QR square. And the PS can be written as 5 times PQ square plus QS square. Okay. It say we also subtracting 8 PT square from it. So minus 8, the PT square can be written as PQ square plus QT square. Okay. Now we are going to simplify it. So 3 PQ square, the 3 PQ square plus QR square, PQ square plus QR square. So it can be written as PQ square plus QR square. It can be written as 3 PQ square plus 3 QR square plus 5 PQ square plus 5 QS square minus 8 PQ square plus minus 8 QT square. Okay, so 3 PQ square, 5 PQ square, 8 PQ square. So they get cancelled. So we are left with 3 QR square plus 5 QS square minus 8 QT square. Okay, QR, we have taken the QR as 3x. So 3x the whole square, 5 times QS. QS is x. X square minus 8 times QT. QT is 2x. 2x the whole square. So 27 x square plus 5x square minus 32x square, that gives you 0. Okay, so what we got? We got as 3pr square plus 5ps square minus 8pt square equals 0. So 3pr square plus 5ps square equals to 8pt square. So it's proved. The next question. It's given in the triangle ABC, AD is perpendicular to BC and BD is equals to 3 times CD. We have to prove this. So it's a random triangle ABC. On that, AD is perpendicular to BC and it is given BD equals to 3 times CD. We have to prove 2AB square plus equals to 2AC square plus BC square. Okay. So it's given BD equals to 3 times CD. BD equals to 3 times CD. So what will be BC? BC, we know that it is BD plus CD. So it is 3 times CD plus CD equals to 4 times CD. So from there we can find CD equals to 1/4 of BC. CD equals to 1/4 of BC. Now, next, in the triangle, for the triangle ADB, what we can write? Angle ADB is 90 degree. So from there we can write AB square equals to AD square plus BD square. AD square equals AB square equals to AD square plus BD square. And for the triangle ADC, we can write AC square equals to AD square plus CD square because this is the right angle, this two are hypotenuse. Now, if you subtract them, you say this is equation 1 and equation 2, you are subtracting them. Equation 2 minus equation 1, we can write AC square minus AB square equals AD square plus CD square minus AD square minus BD square. So we can write it as CD square minus BD square. Or AB square minus AC square equals BD square minus CD square. That is what we can write. Now we know that BD equals to 3 times CD. So we can write 3 times CD square minus CD square, which gives you 8 CD square. AB square minus AC square equals to 8 CD square. Okay. So AB square minus AC square, we need to convert the CD in terms of BC. So CD means 1/4 of BC. So 1/4 of So 8 into 1/4 of BC whole square. So 8 into 1 by 16 BC square. That gives you BC square by 2. Now you cross multiply them. 2AB square minus 2AC square equals to BC square. So from here we can find out the value of 2AB square, which will be 2AC square plus BC square. 2AB square equals to 2AC square plus BC square. Okay, so this is the 9th question. The 10th question is, in the right angle triangle ABC, D is the midpoint of BC. We have to prove AC square equals to 4AD square minus 3AB square. So it's right angled at B. D is the midpoint of BC. So AC square equals to 4 times AD square plus 3 times AB square. That's what we need to prove. So what we can do, let's join the AD. This is a right angle and this is a midpoint. So I need the sides AC, AD and AB. So we have to use those sides only. So for the right angle triangle ABC, for the triangle ABC, we can write AC square equals to AB square plus BC square. AB square plus BC square. Now, in the proof I need AB, so I will keep AB, but BC can be written as twice of CD or twice of BD. So this can be written as twice of BD the whole square. So AB square plus 4BD square. What I did BC equals to twice of BD because D is the midpoint of BC. Now AB square, the BD square can be written as, in place of BD we can write it is AD square minus AB square, because for the triangle ABD, AB square plus BD square equals to AD square. So AB square plus 4AD square minus 4AB square. So AC square equals to 4AD square minus 3AB square. So that is what I need to prove. Next question. It's given for the triangle ABC is a right angle in which C is 90 degree and CD is perpendicular to AB. If BC equals to A and CA equals to B, AB equals to C and CD equals to P, we have to prove this. So let's try to prove it. First, let's draw the triangles. It is a right angle triangle at C. So ABC and CD is perpendicular to AB. CD is perpendicular to AB. BC is given A, CA is given B, AB is given C, the entire AB is given C, and CD is given P. So the first thing we can write it as the area of the triangle ABP, ABC is equals to half into AB into CD. So that is half into CP. In other way, I can find out the area of the triangle ABC. That will be half into AC into BC. That will give you half into AB. So obviously, from the first and the second equation, as both of them denotes the area of the triangle ABC, we can simply write half AB equals to half CP, or AB equals CP. So that's the first one proved. Now for the second part of the question, I have to use the first part of the question to get the second part of the question. So first part of the question, I can get the value of P. So 1 by P from the first proof, I can write 1 by P equals to C by AB. So 1 by P square equals to C square by A square plus B square. Now C square can be written as A square plus B square by, sorry, here I did a mistake. If I square it, it should be equals to A square B square. A square B square. So A square plus B square by A square B square, that is A square by A square B square plus B square by A square B square. So it's coming out to be 1 by B square plus 1 by A square, or 1 by P square equals 1 by A square plus 1 by B square. That is what I need to prove in the second part of the question. Next question given. In an equilateral triangle, prove that the 3 times the square of one side equal to the 4 times the square of the one of its altitudes. So this given for equilateral triangle, prove that the 3 times the square of its one side is 4 times the square of it of one of its altitudes. So we will draw an equilateral triangle. We'll draw one of its altitude. Here for the triangle ABC, we can write AB equals BC equals CA, and it's also given AD is perpendicular to BC. We have to prove 3AB square equals to 4AD square. 3AB square equals to 4AD square. So under the proof it will come. It's given AB equals to AC. So obviously all the angles are 60 degree here. It's equilateral triangle, all the angles are 60 degree. And this is 90 degree. So this will be, two angles will be 30 degree each. So we can prove for the triangle ABD and triangle ADC the congruency. So first thing we can write that angle ADB equals angle ADC. The second thing we can write that AB equals AC, and the third thing we can write as AD is equals to AD. So by RHS rule we can prove that the triangles are congruent to each other by RHS rule. Now as the triangles are congruent, we can write that BD equals DC, which is half of BC. Now for the right triangle ABD or for the right triangle ADB, we can write AB square equals to AD square plus BD square. So we can write AD square, the BD can be written as 1/4 BC square because BD is half of BC. So 1/4 BC square. So it gives you 4 times AD square plus BC square by 4. So 4, if you cross multiply, 4 AB square equals to 4 AD square plus BC square. Now, in place of BC, we can write AB. 4 AD square plus AB square. So in place of BC, we can write AB. So it gives you 3AB square equals to 4AD square, hence proved. Why we can write in place of BC AB? Because it is a right angle, it is a equilateral triangle, all the sides are equal. So in place of BC, we can write AB because all the sides are equal. So that's about everything in the triangles portion. Next day we'll start with a new chapter. Thank you for joining the session.